Hello and welcome to the InfoQ podcast. My name is Wes Rice and I'm your host. In addition to hosting the InfoQ podcast, I chair QCon, a set of software conferences brought to you by InfoQ. The next QCon is in London, March 5th through 7th, 2018. If you like this podcast, you can find 3 full days of sessions focused on innovative architectures and practices just like what we're about to talk about, so check us out. Today, I'm talking to Vitor Olivier about the architecture at NuBank. NuBank is a relatively new, about 4 years old, tech-centric bank in Brazil. They've attracted a lot of attention at recent QCons, and we thought we'd have a chat with them today. NuBank took an innovative approach in how they've architected their system. It's built with a focus on real-time, highly scalable. It's built to be concurrent. It's built with immutability fully in mind as a first-class citizen. They specifically use Clojure, Datomic, Kafka as their backplane. We're going to talk about all of this and the new stuff that they've been working on over the last year. Vitor himself is a software engineer and a partner at NuBank, and on today's podcast, we're going to discuss all about this architecture, what NuBank's about, again, why they focused on immutability as a first-class concern, and then some of the challenges and pitfalls they've tackled in the process. As always, thanks for joining us on the InfoQ podcast. Welcome to InfoQ Podcast, Victor.
Thanks for having me.
I mentioned a little bit about NuBank, but give us the real scoop. What's NuBank all about?
So NuBank really was born with the idea that we could bring efficiency to the financial market in Brazil through technology, data science, and design. Brazil was in a situation in which you have essentially 4 big, well-established banks, and there's not a lot of competition in that world. And very inefficient, terrible customer service, terrible fees. The pricing was just off the roof. You'd see 400% a year interest on the average credit card in Brazil. So really everything just pointed to there needed to be some disruption. There needed to be some competition to bring these incumbents to better prices, better services, better products for customers in general. And our approach to this was, hey, what better way to disrupt this market than through efficient technology built with modern technologies from scratch to allow us to gain the edge over these banks.
How do you do that? I mean, banks, you said there were 4 of them, are these pretty well-established institutions, even with great tech. How do you all reason about jumping into a market like this and start competing right away?
From the beginning, what we thought was we need to compete with these huge banks, right? So what they have experience, they have money, they have a brand that's well established. The only way I can beat them is if I can always deliver, always continuously be improving my product. So it's continuous delivery was essentially the core of how we thought about architecture at NuBank. And it's the kind of thing, like a bank is not something that, I'm just going to have a small little bank over here and it's fine. And I'm not going to, a bank should be big for it to be disruptive, right? That's, and we didn't have the situation in which we need to find product market fit because, banking is a pretty well-established industry. So if we're doing it from scratch and if we're doing everything from scratch, it didn't matter as much the time to market. It mattered a lot more that we built it in a way that we would always be able to improve and keep moving forward, essentially. So with that in mind, continuous delivery was the core of how our tech was based on. And then naturally, right after that, we thought, what better way to start from scratch with microservices? And that's essentially how it all started. Microservices, that makes sense.
Okay, very cool.
The other thing that we quickly learned as we tried to, a bunch of software engineers trying to play with finance, is that finance is hard. And it's essentially math, but it's fairly hard math. And it became very evident that we needed tools to allow us to essentially be able to debug and fix this math. And that's, essentially finance is just applying a bunch of functions to numbers, and we're spitting out a number with interest, we're spitting out a number with some spread, spitting out some number with a fee on it. And so we thought, hey, the functional programming feels like a good fit. Because if you have, I know the inputs to my functions, I naturally know what's going to spit out. So testing, my financial logic becomes a lot simpler because, hey, I know the inputs and here's the output. And if I make a mistake, I can easily reconstruct that. So functional programming was like this is core to the what we wanted to build as well. But that wasn't enough. I mean, we know that there's always going to be a persistence layer. We're always going to have states one way or the other. How do we take it a step further and can allow for us to have this functional, immutable vision of the world, even with the persistent layer?
And that's how you got to Datomics, right? So what is Datomics?
So Datomic is essentially a mutable database where you essentially have two timelines. You have the entities that you create within it, but you also have assertions. Much like Git, you have this each write to Datomic is essentially a new commit to Git, and you can always revert back to the database as of that commit, as of that specific assertion. That was something that we thought, hey, I can always revert back in time and look what was the state on a database when I was doing this specific calculation. And when I'm capable of doing that, I can just feed in those numbers. Oh, this was what was the truth about the world at that specific point in time. I can look, this is the function I applied at that point in time, and then immediately I have time series debugging.
Sweet.
So I know why I charged the incorrect interest. I know why there was some crazy corner case in which we, closed a due balance when we shouldn't have. And immediately, because of the choices in technology, because we thought about immutability at this persistence, at the database level, as well as functional programming, at the business logic layer, we were capable of empowering us to not be super afraid of making mistakes. Now we knew how to revert back incorrect logic. We knew how to essentially fix any problems that we had in production, and we had clear ways of feeding that back into the system. So if I know the bug that happened and I can reproduce it and have this exact representation of the problem, the function that it ran, and the state of the database at that point in time, I can easily just replicate that into a test, and I can guarantee that doesn't happen again. So we think that these concerns, the way we built, really allowed for ease of test, ease of debugging, a lot of clarity on the business logic overall.
It's a super cool architecture, which is why I wanted to talk to you about it. But it's an architecture you commonly see in a lot of consumer-facing, large kind of web property type apps. In finance, where high consistency is the name of the game, it seemed impressive, I guess, at least, that you took this approach. Tell me about that. How do you maintain consistency in the finance world with an architecture that uses Kafka as its backplane, and events could be arriving out of order? They could be doing all kinds of interesting things.
Essentially, there are several steps and processes that we create to ensure that we're consistent with the real world. And the interesting thing is that consistency, there are several possible definitions of consistency when you think about finance in a microservices and any distributed architecture. You can have intra-service consistency, you can have inter-service consistency, you can have consistency with the actual reality of what the customer is doing. And when you're plugged into the financial system, it's not just you that's a system of record, right? It's not just me. MasterCard is also in a way a system of record. The central bank is also in a way a system of record. So it's kind of like the financial system as a whole is a distributed system that needs to be consistent somehow. And I mean, they maybe you can pretend that within your world, well, that's it's a monolith and so everything's consistent. But are you consistent with the rest of the world?
Something has to happen before this other thing can happen, right? Credits and debits that are happening, the T accounts that are in financing. How do you maintain that consistency when you're individual microservices and things could be firing at any time?
Yeah, so there are a few things that we apply, and the first one is, as I mentioned in my talk at QCon, essentially we created one canonical view of the world that's an accounting view of the world. Essentially, it's the contract that we have with the rest of the world, with investors, with the central bank, and we can report our finances in a way that should be consistent to our perception of the world. So there are a few things for that to happen that needs to exist. We need to be able to assert that service is consistent with every other service at NuBank. And the way we do that is through monitoring and sanity checks. So today we have two types of sanity checks. In real time, we're going to create logs on Splunk, and we say, hey, for every time this event happens, every time we publish this message on Kafka, this other message should happen, or this specific transaction log should also happen.
Right. So you check the delta.
Yeah, and in real time, I can see, hey, if there's a delta between the two, there's something wrong. And I can, in real time, take action and make sure that happens. So that's how we essentially handle the real-time consistency. Splunk is great for real time, but when you look at bigger, more robust sanity checks, Splunk is, the way we're using it, at least, it's really going to be focusing on parity of one-to-one. This event happened and that other event happened as well. When we want to really get down to, do the numbers make sense? Is the state of this database, of this this view of the world, the balances on my balance sheet, do they make sense? Then we need to dive a little deeper. The other way we do it is through essentially ETL. We have this ETL of our essentially all our databases, and we can apply a bunch of functions of, hey, this database, if I apply this function, calculate this value, it should be equal to this other database with these values. So essentially, I have a service that's worried about payments, and I can, every day I can run on Spark a function that will look at all the payments that happened that day and look at all the payments that my balance sheet is looking at and see if that makes sense. So not only is the real-time monitoring makes important, because that will help you on the day-to-day firefighting, making sure that your customer is looking at their finances in a consistent way. But you also can find in the big picture kind of world, is this in a more granular way, but for everyone, is this every day consistent? Is this, by the end of the day, is the date closed? Did I close my balance sheet? Does it make sense? And then, so these are the two essentially big checks that we do. And then we add some also, when we're consuming these events into the balance sheet, we add a bunch of essentially checks to make sure that we're not ever corrupting that database. With the credit cards, especially, a lot of the entries that you need to put into the balance sheet depend on the state of the balance sheet at that point in time. So for example, if I'm late by 1,000 reais, so I'm overdue 1,000 reais, and then a payment of 2,000 reais arrives.
So real quick, what's a reais?
Reais is the Brazilian currency.
Oh, okay.
It's about it's 1 to 3.5 of a dollar.
Yeah. Okay.
Let's say I'm overdue 1,000 reais, or I don't know, $300, and a payment arrives of 2,000 reais. There's a late balance, which is an account in my balance sheet, a book account in my balance sheet. I need to move money away from that late balance, but I can't have a negative late balance. So how do I make sure that that negative payment is not going to be making someone owe me negative money? So essentially, the way we do it is, since whenever you have an entry into the balance sheet that also depends on the state of the balance sheet, we're applying some sanity checks, which is essentially generally accepted accounting principles that prevent you from creating entries that will break the mental model of what a balance sheet should look like. So essentially, if you don't have enough of a late balance to consume, that's not just removing from a late balance, it's also creating a second prepaid balance. But it needs to be aware of that. So we have the concept of fixing invariance. And I think on my talk, it's pretty complex. I don't think there are many people even here at NuBank who fully understand it. But in my talk, I think I go through a few examples step by step and gives you a general sense of how we do this kind of transactions.
But it's essentially like looking for certain triggers or certain things that are happening, and then this invariant applies a fix to that. And that may be iterative. There may be multiple invariants that are being applied till it gets into the state that's correct, right? Or what you define as correct.
Yeah, exactly. So it's exactly that, and it really ties together pretty nicely with this event-sourced, functional, immutable vision of the world that we have, in which you have an event that comes in, I apply a function to that event, and then I have a set of entries that are debits and credits. And then I essentially pretend, and with Datomic you can do that, you can pretend to make a database transaction without actually, so you do it in memory and you don't commit anything to the database, you see, wow, what would the database look like if I applied these new entries? And then with that, I get that database and look at that and see, well, is this creating some inconsistent or incorrect vision of the world? Is this corrupting data somehow? And if it is, I don't transact. And then I try to essentially apply the problem that I generated, the invariant that I broke. I apply another function to try to fix it. And then I try again to do the transaction. So essentially, I'll try it 10 times with separate functions saying, hey, this entry comes in, I broke this invariant. The function that I use to fix that invariant is declared here. Use that to try to fix it. And then once I get that result, I try to transact again. And if it works, goes through. If it doesn't, rinse and repeat.
As you're talking here, this reminds me of some of the days that I've spent doing with rules engines and the amount of testing that I had to do to make sure that this rule engine actually validated inputs in the correct way. And it was a ton. You have an interesting way of kind of testing these invariants with property-based testing, right? Can you talk a bit about that?
Yeah, so we use property-based testing or generative testing essentially to find all these potential corner cases. So what we do is we have schemas, and then we have generators of events with those schemas. So you have, for example, the payment schema that will be the representation of a payment as a Kafka message. And I can easily just generate a bunch of payments. We try to have it be pretty narrow, the definition. So, for example, I'm not going to say that the amount is just an amount. I'll say that, this needs to be a positive amount, or this needs to be a negative amount. And then we try to be as restrictive as possible with our schemas. And then we don't just generate payments. We'll generate for every potential event that happens. I have a generator for charges, for bills, for adjustments, for any other thing that will affect a balance. Essentially randomly generate a bunch of events and thousands of events. And then I'll essentially try to transact applying these functions and try to essentially, with a randomized order as well, see what happens when I consume these events. And the idea is that we're capable of finding big corner cases by doing that. And essentially the properties that we're going to be validating are essentially the same properties that that I mentioned, essentially this general accounting principles. Hey, we can't have a negative late balance, something like that. So I can guarantee that I create this, I wouldn't say consistent, because that's not the purpose. It's more of this never corrupted vision of the world. So it's these types of checks are much more about not corrupting the database in a way that we wouldn't be able to recover, rather than ensuring that it's consistent with everything else, right? Consistency we guarantee by making sure that all events that were produced were consumed. We guarantee that each event that should have generated some other side effect generated that side effect. What we do guarantee with these checks is that this canonical representation of the world, my balance sheet, is always in a state that will make sense for me to show my investors. I'll never present my investors numbers that simply don't make sense. Hey, what is this? You have a negative charge for someone. You're just like giving them money. What does that mean? You have a negative late balance. The customer, like you're owing money to your customer. That doesn't make sense. So essentially, it's another layer on top of the consistency concerns that you get with a distributed system.
Very cool. So we talked a bit about the event-sourced architecture. We talked about Kafka a bit as the backplane. You talked about using functional programming so that you can apply pure functions kind of to the data that's coming in, how you resolve and how you maintain consistency. We talked about Datomic and how that's used. One thing we didn't talk about was you specifically chose Clojure as the language. What did Clojure give you?
So Clojure is actually a byproduct of the Datomic decision.
Right. Rich Hickey's the CTO of Cognitect and the creator-maintainer of Clojure, and Cognitect built Datomic, of course. That makes total sense.
Yeah, we really wanted Datomic. We thought that their data representation, data model was super strong. Being ACID on transaction was super important for us. It essentially allowed us to build this immutable vision of the world in a better way. And since Cognitect built Datomic, it just made sense to go with Clojure. One thing that I love about Clojure in general is just that how easy it is for you to notice code that's not functional code. It just makes like imperative and essentially whenever you're breaking functional principles as you're coding, like the code just looks awful. You're like, hey, what is this? I'm doing something wrong here. It punishes you like in a aesthetic way.
Nice. Very cool. So I've worked with several languages on the JVM, but never really had a chance or never tried Clojure too much. I have seen lots of nice presentations that use Clojure and ClojureScript at QCon, and also Alex Miller, Strange Loop. He's a developer at Cognitect, if I remember right. So there's usually a bunch of things there that hit on Clojure.
So I got to ask one question. All right, so the architecture sounds super cool, and when we're developers, so cool often leads. But there's also a tremendous amount of complexity here, right? As you're talking about microservices, that alone introduces a lot of complexity. All the checks and then the invariants that you just talked about. You just said, like, you're not even sure that everybody at NuBank could tell you exactly how invariants work. And then Datomic's on the back end and Clojure, and it's a startup, and you're trying to break into the market. That seems like a lot of complexity. How did you manage all that complexity, the learning curve, and all the things that come with that complexity?
What ended up happening here in Brazil especially is that we have a fantastic talent pool that's, at least in my opinion, in a controversial opinion, that's essentially being underutilized by big companies with a very old stack, not empowering, not valuing essentially software engineer work in Brazil. It's kind of, I think it'd be weird for, people who work in Silicon Valley or New York to even understand it. But in Brazil, engineers are still second-class citizens in most big companies. So they're not going to even make that much money. They're not going to be valued as much. So what ended up happening was that bringing this world in which, hey, software engineering is the core, you're the superstars, and we're doing all these cool things. Our stack is awesome. All the things that you wanted to work with, you never got the chance. We ended up having this amazing self-selection. So essentially people who, these guys are doing functional programming, Clojure, Datomic, Kafka in 2013, 2014.
People wanted to come work for you, yeah.
You're like, yeah, I'll do it. And it just makes sense. So I would say, from the beginning, we've been able to get fantastic talent, as well as people who are very entrepreneurial by nature, people who are willing to take risks, people who want to learn more, a lot of hunger in our team. So it's pretty fantastic. And as we scale, and now I think we just crossed the 100 engineer mark. Naturally, as we're growing, that becomes harder and harder because the domain becomes harder and harder. The complexity of this world is more difficult. Now we're getting to the world in which we need to compete with, for global talent, not just local talent. And that's why, for example, we just recently opened an office in Berlin, and we're essentially trying to grow our engineering team, to really be world class. I do think we're already world class, but it'd be nice to be globally represented as well.
So as we were talking before that we actually started recording the podcast, you were telling me a bit about some of the work that you've done over the last year. The architecture that we just talked about at least started with kind of the credit card processing work that you had done, but you've now taken that and grown it into a new area. Can you talk a bit about that work over the last year?
Yeah, so over the past year, I led this new team for a new product at NuBank. It's called Nu Conta, which essentially means new account. It's savings/checking account built for real-time transactions here in Brazil. And the same way with the credit card, credit card, you have terrible interest rates and you have terrible fees. The same is true for a savings product in Brazil and a checking account product in Brazil. You're going to have ridiculous fees for transactions. A wire transfer could cost you up to $3-4 for one single wire transfer. And then the yield that you're going to get on a savings account is, probably only 60%, 70% of the tax-free rate. So, there was a lot of pain in that market. So we came from the same types of pain points into a second product. And as we're building that product, I think the general architecture, the principles were the same. We still very much loved microservices, the flexibility that it gave us, the capability of developing things in parallel, the idea that you can decouple a lot of the logic. We loved immutability, we loved Datomic, we loved Kafka, we loved Clojure. So I think the big principles that we had in terms of architecture remained there. And then it really came down to what are the mistakes that we made with the credit card and how can we not fall for the same mistakes or at least try to make new mistakes. So there are a few things that we kind of like tweaked to get to a more robust architecture in our perception of what that would look like.
Okay, I got to ask because these are the cool things. What can you give us a couple examples? I mean, what are some of the things you had to fix? I mean, tweak for the new system that you built.
I guess the first thing that popped to mind is that, for example, okay, so credit card 2014. We're building microservices, so we had this geo microservice that would look at all the geolocalization logic of whenever someone makes a transfer, you know where the person is, and you have this auth service that handles authentication, and then you have a service that's called accounts. That's all the financial data, all the financial logic for a credit card business. And it's like, well, that's
a monolith.
That's pretty much the definition of a monolith. It's just pretending that it's not, right? And then after a while, with a credit card, we say, hey, this doesn't make sense. We need to split this account service. And that account service actually became 4 or 5 services later on. And splitting accounts was very painful. But in one specific case, we built 2 services when it should have been 1. So we split too much. Essentially, we have a billing service and a line item service. And a line item is just an item of a bill. And a bill is essentially a collection of line items. And sure, there are presentational things that are specific to bills. There's a bill cycle, and line items are also affecting the customer's limit and things like that. But you immediately see that, hey, if line items is down, billing is going to be down. You're going to have it's coupled in a way that it just doesn't make sense. 2 teams would not be able to maintain these services separately. So one thing that became very clear, and this is just one example that's easy to explain, but there were several other cases, is that understanding the boundaries, when does it make sense for me to create a new service? When does it make sense for me to split a service? Was something that was key to making sure that microservices would work.
So how does your definition of that bounded context change, or not change, but redefined as you move to this new system?
So I think it's that there are several things that needed to happen for us to have a better idea. I think the first one, and I can't stress this enough, is understanding the domain. So early with the credit card, we're new to finance, we're new to banking in Brazil, we're new to everything. And so it's very hard to be able to understand what's the context, how do I bind this context in a way that makes sense. So gaining a lot of context will help you understand where these boundaries are. The other way is that I think before we either defined a service as something that was way too broad of an action. For example, think about billing. Billing someone means that you're going to create a bill, you're going to find a balance for that bill. You're going to need to, for you actually bill the person, you need to send a notification for that bill. You need to understand if that bill is paid or not. So maintain some type of state on that bill. And it's just a lot of things if you think about the act of billing, right? As a whole, as is just creating a bill enough for me to bill someone? No. So this is not a billing service. This is something else, right? So even naming things was important. If you name something that's too broad of a thing, you're going to end up with something that's way too broad, way too big. Accounts, right? It's something that, hey, anything could be in accounts.
So what did you ultimately settle on? What did you name that billing previous service, for example?
In our case, we kind of threw it out the door. It's like, hey, the name does not make any sense as to what they do. It's like, I'll just name something random, character, something that's fun. I don't care. But and then the definition of what it does is literally one very well-defined feature of the product. So you're going to see, for example, in our case, transfer, what are the things that you need to do for you to use an account? You need to get the money in. You need to earn some interest on that money. You need to get that money out, right? So transferring in, get that money in. Be the system of record of when the money came in. That's one thing. Money out, all right, that's another thing, very specific. If I call a service transfers, what's the transfer? Is it transfer coming in, transfer coming out, peer-to-peer transfers? Each of these things will have very different business logics, entities, dependencies. So it's not a transfer service, not two transfer services, like specifically money coming in from another bank, money coming in from internal. And then slowly, it's like you bind that to a very specific kind of feature, it becomes easier. So that, because of that, if you look at the way we build things, the very beginning, we spun a bunch of services. We like went from 0 to 10, boom, immediately. And I mean, naturally, there was a lot of like, hey, does this make sense? Are we just not like shooting ourselves in the foot? Maybe it's a little too much. And it felt like, well, maybe we're just, the key is we need to, very small services, something that makes sense for this business. And then slowly, as we got to, for example, balances, keeping a balance, I need to calculate interest. All right, so that's one big concern. I need to make sure that whenever there's a new deposit, that's recognized that it's part of the balance. Okay, so I recognize interest rate, any money that comes in. If the money comes out, I need to remove that balance from that service. So, that's also a concern of this guy. And then essentially what happened is that, now we have this one central service that's a lot bigger. And is this like a deviation of the rest of the things? And then what became evident is that a service should have access to all entities for it to answer the key questions that it needs to answer. So if I need to be able to, someone say, hey, what's someone's balance? I need to be able to ask one service like, hey, that guy is going to give me the balance, and he's not going to make any requests to any other service, and he's going to own all the entities that are related to that specific feature of the product. So for us, that was essentially the core.
It's sort of the Unix philosophy, right? Do one thing and do it well and completely. You're saying the service needs to be able to fully represent the feature that it's implementing.
The service needs to be able to create this full representation of the core feature that it's handling. And I think if you look at essentially the problems that we had in the past, oftentimes you'll say, well, this is distributed system problems. I think a lot of that can be solved by just understanding your domain in a level that's not trivial. It's a level that's not like, hey, I'm going to whiteboard this for a few weeks and I'm going to architect this. It's like understand it in a way that's just insane. The way we got to do this, and it was pretty interesting actually, and I think maybe this also helped. With a credit card, we're in a startup mode. We need to be alive. We need to show product progress. We're building the app at the same time as we're building the backend. And with that, what ended up happening, what I think was a problem, is that a lot of the business logic got mixed into presentational logic. Hey, I need to show this screen, so I need an endpoint that actually shows me this, and I need to ask that for some service, and that service, I need that screen, but that entity doesn't live here, it lives somewhere else as well. And now I have all these dependencies for that one specific endpoint that's literally just to show that to the customer. The way we build things is we started with a design team at the same time as engineering team. Design team was doing research, literally just research, trying to understand the problem that we needed to solve. And we're building the things that we knew needed to happen. I need to get the money in. I need to get the money out. I need to calculate interest. That needs to happen. Doesn't matter. So we're building these things. And then we finally get the design and we're like, all right, now we need to present all this data to the customer in a way that makes sense. How do we do this? Well, I think it makes sense for us to create some service that's sole responsibility is to present data. And the way we build that is through a GraphQL server. That is the guy who, consumer driven, a server that's focused on, hey, you need this for a screen, just query me and I'll show you what you need. I'll be worried about what you do. And then before with a credit card, you're passing hypermedia around. It's like, this entity, and for you to get more, you need to ask this other service, and you're going to get 20 hyperlinks to.
So the new system used GraphQL, the credit card system did not?
Yeah, exactly. So the new system is using GraphQL.
Okay, so that's pretty interesting too. GraphQL is super popular now. GraphQL came out a few years ago. It was originally designed by Facebook, designed as a way to make it easier for front-end developers to fetch the right data as they were working on mobile apps, things like that. So tell me about how it helped NuBank with your application.
Essentially, you take away a bunch of dependencies that happen just because of the way you want to present the data. And you can really focus on, hey, you're just a service that's focused on the business logic for this part of the feature. And it doesn't really matter. Like, I don't need to fetch. And one thing that ended up happening because of this, you have very, very, very few gets from one service to the other to actually, process an event. It's very rare for it to happen. And when it does happen is just to find someone's customer ID or account ID, things like that.
So you basically had GraphQL that sat on top of all your kind of existing RESTful endpoints and then could be able to deliver a more front-end developer-friendly set of APIs that they could consume for the mobile app, right?
Exactly. And you abstract away essentially all the distributed system complexity from the mobile development. So mobile development, hey, it's just, this is declarative.
This is what you need.
This is what you need. This is what you can get. Doesn't matter. Like there's a lot of business logic embedded into the app that stems from.
It was a new monolith, just like you talked about before. That service was a monolith. The mobile app became the monolith where everything was calling everything, right?
Exactly.
So I'm curious. So as you were bringing in GraphQL, any issues as you were doing it? Any areas that were sticky? Anything like that?
Nothing that was not surmountable, I guess. Like I'm very happy with this GraphQL stack. We're in the front end, we're using React Native and Relay. We think it actually sped up the mobile development a lot. We're really enjoying it. And even for debugging, and we see the account as the platform for a bunch of new products to come in. So now that I have an account, I can have maybe a lending product, maybe, insurance, maybe, I don't know, payments, so whatever. Any other product would come from a basic account. I need to have the money in, money out kind of stuff. So having this interface for any other product as well, not just for the mobile apps, like, hey, you want to consume data from the account to understand if you want to give someone a loan or not. Here's the GraphQL API. You don't need to worry about all our services. This is my interaction with the world. This is the contract I have with the rest of the world. And I abstract away a bunch of the distributed system complexities that you'd get in another situation.
We didn't dive too deep. We kind of just talked about the architecture and kind of some of the things you'd solved. But if you want to learn more about the architecture of NuBank, there's a couple talks out there. One Vitor did that's called Functional and Microservices in Real-Time Financials. That was at QCon New York, find it at InfoQ. And then another by Edward Weibel, his CTO at NuBank, who talked about architecting modern financial institutions. So check out those talks if you want to learn a little bit more. And as far as this new product, we'll have to get Vitor at another QCon to talk a bit about it.
Sounds good.
Vitor, thanks for taking the time to chat with us.
Thanks for having me.